Hello everyone at home. Welcome to our lesson on graphing a linear function. This is Mrs. Beckman here. I'm going to hopefully help you by the end of the lesson learn two things. One is being able to evaluate functions given an input, and two, being able to graph a function on the coordinate plane. Okay, so if you guys were in class yesterday or if you watched the video, you learned what a function was. Okay, so if you remember, a function had to have the domains paired with exactly one y. And if they didn't, we said it wasn't a function. Okay, so there's all different kinds of functions. Today we're going to talk about linear functions. And so if you think of the word linear, it means it forms a line. So today we're going to be graphing lines. If you don't get a line in today's lesson, you probably made a mistake. So keep that in mind today. All right, so a lot of teachers will talk about a function machine to help kind of explain things. But basically, we're going to be putting in x values into this machine. And this machine is going to be doing the exact same function to it. So maybe the machine is just adding 2 to every number. So if I put in, let's say, 3, and it added 2, it would output a 5. If I input a 7, it would add 2, it would output a 9. Okay, so today we're going to have this really, really fancy function machine. Super fancy. And that function machine is your brain. Okay, so we're going to be inputting x's into your brain, and your brain is going to be outputting the correct number. All right, so here are your steps. Step 1 is to choose 5 input values. Now, we always want to choose the easiest values, and we always want it right in the middle of the graph. So I always recommend doing 2 negatives, 2 positives, and the one right in the middle is 0. And if we're talking about the easiest numbers to deal with, we talk about 0, 1, and 2. So the 5 values that we're going to choose today are -2, -1, 0, 1, and 2. So we're going to input those 5 values into, remember that really fancy function machine, your brain, and we're going to output a y. And once you have an x and a y, you have an ordered pair that you can now put on the coordinate plane. So we can now graph it. Okay, so let's see what this looks like in action. Now, before I get started, I want to clarify, this spot is optional to show your work unless you keep making mistakes, and then we definitely want to go back and make sure we put our work in there. I am, for this lesson, going to show my work so you guys can kind of see what I'm doing. Okay, so I'm going to go through the 3 steps. Step 1 is to choose those 5 values. So we always do -2, -1, 0, 1, and 2. And we want to put it in that order because we want to see a pattern, and I'll show you where that pattern appears here in just a second. All right, so here's where we use that really fancy function machine. This function machine is telling us to find y, we have to take our x, which we're going to have to plug in, and we're going to have to add 7 to it. Okay, so take your x, which was -2, add 7 to it. Well, my fancy function machine is telling me that that answer is 5. Okay, so let's do another problem here. Take your x, this time our x is -1, add 7 to it. That gives us an answer of 6. Okay, we're going to do another one here. Take your x, which was 0 this time, add 7, we get 7. And we're going to keep doing this. Take your x, which was 1, add 7, we get 8. You guys should notice a pattern. If you do this correctly, there should be a pattern. Okay, so take your x, add 7, we get 9. Now notice we had a pattern. You could even tell me what the patterns were. They're going up by 1. That's good. If you get a pattern, that's really good today. We want it to be a constant rate of change or a constant pattern. Okay, the next step then is to graph these points. So I'm going to graph this ordered pair -2, 5. So this is where we practiced last week with making those pictures. So we're going to go left 2 on the x-axis and up 5 on the y-axis. Okay, so I'm going to do the next one, -1, 6. That would be left 1, up 6. The point 0, 7, that would be left to right 0, but up 7. Again, just like I said your table should make a pattern, our points should also make a pattern. If they are not making a pattern, we probably did something wrong. So I'm going to graph the point 1, 8, go right 1, up 8. Then I would plot the point 2, 9. I'd go right 2 and up 9. And if you did this correctly, we should get a straight line. Now I could have chosen any x values, but I wanted to choose the easiest ones. But if I chose more, I would get more points on this line. So to show that this line is not just these 5 points, but there are lots and lots of points, I'm going to draw a line through it and put an arrow showing that there are more points. I'm just not going to spend the rest of my life plotting them, because that's what I would be doing. It would keep going on and on and on, because I would never have an end point. Okay, so let's try another one like this. All right, this one looks a little bit different because it says f of x. Remember how I talked about our function machine and that you plug in an x and your fancy brain changes it and out comes a y? Well, that is what this means, that it's just a function of x. In other words, fancy way of saying y equals here. Okay, so if that confuses you, you can cross out and put y equals, but a lot of time, especially in high school, you will see f of x. That just means a function of x. In other words, you plugged in x and out popped this number. All right, so again, we start with our 5 values of x that we're going to constantly use, and we plug them in. Now this one's a little bit tougher because we have 2 operations. We have multiplying and we have subtracting. So you can use your calculator if you need to for this. I'm going to show my work. I'm going to do 2, and if you're using your calculator, you have to remember to put in -2 in parentheses when you plug it in. Okay, so order of operations, do I subtract or do I multiply? Well, I multiply first. So -4 minus 10, I would get the answer of -14. Again, hopefully you get a pattern here. If you get a pattern, that's always a good sign. All right, so this time I'm going to plug in the number -1. Again, I multiply first. So -2 minus 10, I would get the answer of -12. Okay, so let's try another one. Plug in the point 0. 2 times 0 is 0 minus 10 is -10. I'm coming up with a pattern so far, so that's a good thing. All right, so let's plug in 1 this time. 2 times 1 is 2 minus 10. That would give us -8. And the last one here, if I plugged in 2 minus 10, 2 times 2 is 4 minus 10, I'd get the answer of -6. All right, so do I have a pattern? Yeah, I do. It's actually going up by 2 each time. Now, here's another trick that I think is pretty cool. It's going up by 2. That's the pattern, right? Going up by 2. Look at where we see 2 in our equation. We see 2 as our coefficient. It should always match our coefficient. So if I looked at the one we did at first, our pattern on this one was going up by 1. And again, if you look, what technically is our coefficient? It's that Ninja 1. It matched. So the pattern should always match your coefficient, which I think is always a really cool thing. It's a great way to check and see if you're doing things right. There's a lot of ways to check your work in these problems. All right, so let's now graph to hopefully get the right one. Now I have a problem. The first 2 go off my graph here. So I'm not going to be able to plot -2, -14, or -1, -12, which is fine. I'm just going to start at then 0, -10. So I go left to right 0, but I go down 10. For 1, -8, I go right 1, down 8. And for 2, -6, I go right 2, down 6. And hopefully, if you did it correctly, you should have a line. Again, we draw arrows showing that I could get a lot more points, but I'm not going to spend the rest of my life doing it. Okay, so let's do one more example, and then I'll have you guys try one on your own. All right, so again, f of x is just a fancy way of saying y equals. We choose the same 5 values, -2, -1, 0, 1, and 2. Now that we know kind of what that pattern is, I'm going to look at my coefficient. I know that I should have a pattern of going down 1. So keep that in mind as we go through this. All right, so let's start off with, there is also, I'm going to draw in my coefficient here of -1. So when I do my work, I don't get confused. So that's -1 times -2 minus 4. Well, a negative times a negative is a positive. So 2 minus 4, -2. All right, next one, -1 times -1 this time, minus 4. Well, that would be +1 minus -3. Okay, do it again for 0. -1 times 0 minus 4. Well, when I multiply there, I get 0 minus 4. Okay, this time -1 times 1, which is going to be -1. And when I subtract 4, I get -5. And last, -1 times 2 minus 4, which would be -2 minus 4, which would give me -6. Notice, I must have done something right, because what was happening to my numbers? They were going down by 1, which again matched my coefficient. So a nice way to kind of self-check. All right, so let's plot our points. -2, -2 would be left 2, down 2. -1, -3, left 1, down 3. 0, -4, down 4. 1, -5, right 1, down 5. And 2, -6 would be right 2, down 6. Again, you should get a line or you plotted your points incorrectly. Okay, go ahead and try this one on your own. And go ahead and pause the video because I'm going to show the answer here in just a little bit. All right, here's what you should have done. So you should have had those 5 values. Again, it would be -1 in parentheses plus 3. I'm going to go ahead and fill those out for all of them. So I multiply everything by -1, and then I add the 3 to all of these. So if you did your math correctly, the first one, you would have gotten +2 plus 3, which was 5. The second one, you would have gotten +1 plus 3, which was 4. The third one, you would have gotten 0 plus 3, which was 3. The fourth one, you would have gotten -1 plus 3, which was 2. And the last one, you would have gotten -2 plus 3, which was 1. And guess what? Our pattern was going down by 1, which matched our coefficients. Okay, now let's see if you plotted your points correctly. Did you go left 2, up 5, left 1, up 4, straight up 3, right 1, up 2, and right 2, up 1 to get a line that should have looked like that? All right, if you did, try the one on the right. So if you got it right, try a challenge. If you got it wrong, try one like the one you just did, but just an additional practice. All right, go ahead and pause the screen now to give you some time to work. And when you're ready, hit play again and I'll go through the answers. All right, here should have been the answer for the first one. So -2, -1, 0, 1, 2. Again, -1 times our x on all of these, and then subtract 1. So -1 times our x, subtract 1. Sometimes it's easier just to fill them all in at the beginning like I'm doing. And then we plug in -2. So that would have been +2 minus 1, 1. This would have been +1 minus 1, 0. This would have been -1 times 0, which is 0 minus 1, -1. Plug in 1, that would have been -1 minus 1, -2. And last, that would have been -2 minus 1, -3. So if you plotted that, it would have been left 2, up 1, just left 1, just down 1, right 1, down 2, and right 2, down 3. Your graph would have looked like that. All right, now if you got the hinge question right, you would have had this challenge, y equals 5. Again, choose your normal x values. But here's the hard part. There's nowhere to put in an x. So what does y equal? Well, a lot of you guys were overthinking it, I'm guessing. Y just equals 5. Each and every time, because there is no x, the y is constant. It's constantly 5. So if I plot this point, left 2, up 1, 2, 3, 4, 5, and left 1 up 5, we would get a special kind of line. We would have gotten a horizontal line. And that would have been your answer to that one. All right, we are going to do 3 more examples, but we're going to get a little bit tougher. This time, instead of having our normal coefficient of just a whole number, we're going to throw in fractions. And because we throw in fractions, we're going to choose different x values. Because if I have 1/4 times x, I don't really want to multiply this by 1, because 1/4 times 1 is going to give me a fraction, and I don't like fractions. Yuck. Okay, so I'm going to be smart about the x values that I choose. I know that 1/4 is basically like dividing by 4. So I'm going to choose numbers that are easy to divide by 4. So like 4 is easy to divide by 4. 8's easy to divide by 4. So I'm going to choose numbers that are multiples of the denominator. Okay, so that's going to be the difference. We're going to choose multiples of the denominator for our x values. We're still going to use 0, put it right in the middle. We're still going to do 2 negatives, and we're still going to do 2 positives. So again, we look at our denominator, and we're going to go up by that number. So I'm going to start at 0, I go up by 4, so 4, 8, and then I'm also going to do the negatives, -4 and -8. I'm going to try to keep it in a pattern from least to greatest, because if I keep it in a pattern, my y's are going to be in a pattern, or my ranges are going to be in a pattern, which is a lot easier to see if I make a mistake if there's a pattern. Okay, so let's practice one. All right, y equals 1/2 x minus 10. So again, I'm going to put 0 right in the middle. I'm going to look at my denominator. It's 2, so I'm going to go up by 2's. So 0, 2, 4. Now I have to go backwards and do the negatives. So if I subtract 2, I'm going to do -2 and -4. Keep this in order from least to greatest, like so you have that pattern. Okay, now if you want to use a calculator, feel free to use a calculator. A lot of you guys don't have to when you take a half of a number. So I'm going to do a half times something minus 10. A half times something minus 10. A half times something minus 10. Half times something minus 10. Sometimes I tell my students to start with the one that they think's the easiest. I think multiplying things by 0 is super easy. So I'm going to put in 0 first, because anything times 0 is 0. So I have 0 minus 10, which would give me -10. Okay, now, which is easier to plug in, negatives or positives? I personally think positives. So I'm going to plug in 2 next. What's a half of 2? Well, I know that half of a 2 is 1. So 1 minus 10 is -9. All right, next up, I'm going to do the next positive, 4. Half of 4, I know is 2. 2 minus 10 is -8. Now, once I have a pattern, I can probably fill in the other 2, but just to be sure, because sometimes negatives can kind of get tricky, I'm going to actually do these next ones. So half of -2 is -1 minus 10, that would be -11. And a half of -4 is -2 minus 10, that would be -12. Again, I have a pattern, which is good. Now, it's a little bit trickier to match your coefficient. It still works, it's just a little different. So if you notice, our y's, or our ranges, had a pattern of going up by 1. Now to get the 2, you have to look at your x's. Our x's, our domains, were going up by 2. So the y's were changing by 1, the x's were changing by 2. That's where the 1/2 comes from. All right, so let's see if we can plot these points. Well, the first 2 go off the graph, so I can't use those. So I'm going to start with 0, -10, which would be right behind this picture. The next one would be 2, -9, so I am going to have to move this picture. I would go right 2 down to 9, And then the last one, right 4 down to 8. Again, draw the line with the arrows showing that you can choose a lot more points. Okay, let's try another one like this. All right, this one is -1/3. Again, be smart with choosing your x values. That's the most important part. So start with 0 in the middle. Find your denominator, go up by that number. So I'm going up by 3s. So 0, 3, 6. Now I'm going to do negatives. -3, -6. Okay, so I'm going to rewrite this, but just putting a parenthesis where the x was. I can do it all at once. Again, I'm going to do it like I did the last one. I'm going to start with the one that I think is the easiest. And I think you guys all would agree that plugging in 0 is the easiest to do because anything times 0 is 0. So I'm just left with 2. Okay, I'm going to plug in, let's do a positive here. -1/3, again, you can use a calculator if you need to. A lot of you don't have to, which is fine, but feel free to use one if you need to. -1/3 times 3/1. If you notice, the 3's are going to cancel out to be 1's. So this would be -1, but don't forget to add that 2 to give us an answer of 1. Okay, let's plug in 6 out to the side here. I'm going to do -1/3 times 6/1. The 3 would become a 1, the 6 would become a 2, this would be -2. Again, don't forget to add that 2, which would give me 0. We should have a pattern here. So I could fill in the rest of this, honestly, without even doing the math. But again, if you want to check, we can check. -1/3 times -3. I would cancel those out and I'd get 1's. But this time I would have a negative times a negative, which would be +1 plus 2, which that checks out. And I'm going to assume that this one also checks out since everything else followed the pattern. And if you want to see how that matches your coefficient, again, these went down 1. These went up 3. That's where it matches your coefficient. If that's confusing to you, that's fine. You don't have to worry about it. I just wanted to show you kind of a cool way to check your work as you go. But let's go ahead and plot our points. So we would go left 6, up 4 for the first point, -6, 4. So left 6, up 4. The next point is -3, 3. So left 3, up 3. Then we have 0, 2, which is just up 2. Then we have 3, 1, which is right 3, up 1, and then we have 6, 0, which is just right 6. And this would be our graph of this equation. All right, last one. I threw in another one that was special. Y equals -1. All right, no fractions, right? So go back to your 5 that you're used to, like we did at the beginning. And remember, we're trying to plug in an x. Uh-oh, but no x. So what does y equal? You guessed it. It equals -1 every single time. So if I plotted these points, I would go left 2, down 1, left 1, down 1, just down 1, right 1, down 1, and right 2, down 1. All right, I know that was a super fast lesson. Please don't hesitate to reach out if you guys have any questions. You do have homework tonight. I did post the answers if you need to check and see how you're doing. Hope you guys are doing okay, and we hope to see you soon. All right, see you guys.